Good morning, Year 6. It is Monday the 13th of July, and today we are looking at area and perimeter. So, our first anchor question, match the rectangle to the correct area and perimeter. So we know to start with, our first clue is that we have here squared. So we know this is all area. These three measurements are all area. Okay, and these are the perimeters. So let's have a look. So 5 centimeters and 11 centimeters. To work out the area, we just do length times width, and that's the inside. So that is 55. Here, perimeter then, so is you can either do 5, add 5, 11, add 11, or add them all up. So 5 add 11 is 16, and 16 times 2 is 32. 9 times 2 is 18, and then 9 add 2 is 11, times 2 is 22. So this last one we can see is clearly a square. We've got one measurement. So 9 times 9 is 81. And then 9 add 9 times 2 is 36. Our next question. Use the correct formula. Calculate the area and perimeter of the shapes below. So we know the correct formula being for area is length times width. And perimeter, we just need to add two sides together. So we could do add, and add. Or we can add two sides together of different lengths. And then times by 2. Okay, whichever way you'd like to do it. Okay, so let's have a look here. So the area of A equals, well, different measurements here, different units of measure. So here I'm just going to convert this to meters, so 5 meters. So I've got the same unit of measure, so 9 times 5 I know is 45, so 45 meters is the area. The perimeter, remember what we said here is we add the two sides together and times by 2. So 9 add 5 is 14, so 28 meters. I missed here, units squared. Again, it has to be meters squared. Here, again, we've got two different units. So what I would do is I'd convert this 8 millimeters to 8 centimeters. Again, area, we know equals 8 times 14. So thinking about it, I know what 10 times 14 is 140. I need to take two lots of 8 away, which I know is 16. So it's 130, 124 centimeters squared. The perimeter then equals 8 add 14, which is 22, and 22 times 2 is 44 centimeters. Okay, so we're going to have a look at the video today that'll help you with your learning.
Hello there and welcome back. Today we're going to have a look at using area and perimeter. And we're going to start off with a bit of an insect problem. So here we've got an ant and he's going on a little journey across this board. So watch carefully. I want you to think about how far has the ant travelled. Let's watch him go. So we've got this red line to help us here. So how far did the ant travel? Let's think about that. Well, we could add up the individual lengths. So we got this top length here of 5. Then he went down. He went down 2 squares. So we could add that to the 5 we already got so far. And we could carry on doing that, adding up all the lengths. And then to find out his total journey, we could just add them all together. Well, 5 add 2 add 2 add 2 add 7 add 4 is 22. So in total, he went 22 squares in distance. This is called the perimeter. And we can think about the perimeter being the total length of the sides of a polygon. So, one for you to think about straight away then. Can you calculate the perimeter of this shape? So pause the video, have a go for yourself. Okay. Hopefully, you could either label up the lengths or just visualize them. So we could do 7 plus 5 plus 5 plus 1 plus 2 plus 4, which was 24 squares is the perimeter of the shape. Or you might have thought about, well, I know the 5 and 5 was 10. I could have added the 1 and the 2 to make 3. I could have also seen that together that would be another 10 with the 7. So I could have seen it was 10 plus 10 plus 4, which was 24. So we've got two figures here. Which has the greatest perimeter? So pause the video, have a think about that question for yourself first. Let's think of that word perimeter. The word perimeter means the total length of the sides of a polygon. What about this word polygon, though? It's a closed shape made of straight lines. Well, both figures are made out of straight lines. But the one on the right isn't closed. So actually, the one on the right doesn't have a perimeter we can measure. So it will be the one on the left. So we've got here a rectilinear shape. Mo says, we can't work out the perimeter of this shape because we've got one of the sides the missing of the length. Dora says, you can. Who's right, you think? Well, let's take our rectilinear shape. We've got this length 6 here. And let's take this yellow length, which is 4, and the green length, which we don't know. Let's just move, or imagine moving that line across that's length 6. Well, we can see that the red length is equal in length to the yellow and the green. We can see that they're equal length. So that must mean that green plus yellow is equal to red. So 6 is equal to 4 plus something. Well, that must mean that the missing length must be 2. So we could work it out after all. And we could add them together to make 22. So, 2 for you to have a go at Adam. Can you work out the perimeters of these shapes? Pause the video, have a go for yourself. Let's have a look at the first one. Well, we don't know this length here, but we can work it out because we know this length and this length together are equal in size. So therefore, it must be 8 centimetres. Well, and again, the one on the left, well, we know yellow plus green must be equal to 5. So 2 plus something is equal to 5. Well, that'd be 3. So the perimeter would be 26 centimetres. What about the one on the right? Well, the missing length would be 1.5 and 2. So the perimeter would be 26 again, or this time 26 miles. So, how many ways can you calculate the perimeter of the blue rectangle? Pause the video, have a think for yourself first. Let's have a look then. Maybe you filled in the opposite sides and then added them up. So 8 plus 5 plus 8 plus 5. Perhaps you thought, well, I know there's going to be 2 8s, and I know there are going to be 2 5s, so I could do 8 times 2 plus 5 times 2. So all you may have just done, well, I could just add 8 and 5 together and then double that, which would have given you 26 as well. So, have a go at the green shape. Pause the video, calculate the perimeter of that one. How did you get on? Did you find anything out? Well, one way you could have done it is just add up all the lengths, which would have given you 26 as well. That's interesting. And we could have just done it as 8 times 5 times by 2. How does that work? How does that... I can't... hang on. What if I visualise moving that length 6 line vertically up? And I can see that if I did those 2 lengths, it would have been 8. can you picture where that 2 could go? Well, if I moved it here, I can see that the 3 and the 2 would have it together to make 5. So actually, it's the same rectangle as the blue shape. That's a really interesting way of doing it. Now, one thing to be careful of is this only works for certain shapes. So be careful and look at the shape that you're working with. So then, we've looked at perimeter. We just think about the outside of the figure being the perimeter. But what about the bit in the middle? If I take that out, I can visualize it. And we know this is the area. The area is the space inside the flat object. So can you visualize the areas of these shapes? Well, hopefully you could have seen, well, the triangle would have been this space in between. So it would have looked a little bit like this, the area. And this pentagon, irregular pentagon, the area would have been here. But the one on the right is the space inside a flat object, but it needs to be closed. Well, actually, the one on the right feels like it could fill up the entire world. It's never going to end. So actually, we have to have a closed shape to be able to measure the area. Now, we know the area of a rectangle, and thinking about the formula, is filling it up with squares. So how many squares could fit inside this rectangle? Well, there would be 20 squares. Now then, Whitney says the way to measure that could be, well, I could see how many were in a row, and then think about, well, how many rows are there going to be? Well, 2 rows, 3 rows, 4 rows, and 5 rows. So she did 4 times 5 to work that one out. Teddy said, I could have seen how many squares were in a column, which were 5, and then think about how many columns were there. So 1 column, 2 columns, 3 columns, 4 columns. So Teddy did 5 because there's 5 in 1 column, and then saw there are 4 columns, so there were 20 squares altogether. So then, can you calculate the area of these rectangles? Pause the video, have a go for yourself first. How did you get on? Did you notice anything? Well, you may have noticed that all the rectangles have the same area. How can that be? Well, let's compare the purple and the blue rectangles. They look a bit different. But if I rotate the blue one, I can see that they're the same size. But what about these? They don't look the same. But if I overlap it, and if I move a part of it, I can see actually, yes, they've got the same area. I just might have visualised moving part of it about. Now we can measure area in centimetres squared. So this little square, or the area of it, is 1 centimetre squared. So this square, it's got 4 of those, so it's got an area of 4 centimetres squared. So how many of these little centimetres squared could I use to fill the blue rectangle? So, have a think for yourself first. How many would fit inside that rectangle? Maybe you thought about filling up either a column or a row. And then how many would be in the whole side? Well, I could multiply it together. I could have done 4 times 6, which would be 24 centimetres squared. And we think that the formula for the area of a rectangle is length times width. So in this case, it would be 6 centimetres times 4 centimetres, which is 24 centimetres squared.
Okay, have a look at the worksheet that is been emailed to you, and don't forget to have a go at your learning by questions.